Good afternoon, everybody. Today I am going to talk to you on metal forming processes. Basically, metal forming processes are divided into two parts, two categories. One is forming and second is shaping. As we know, forming means changing the shape of an existing solid body. For example, metal body of a car. If you see, metal body of a car is made of a plain sheet. With the help of dies, you change the shape of the sheet and you make it into a body of a car. Or for that matter, if you take a metallic cup in your house, this is also metal forming operation. Then there are others, shaping of metals, that usually involves molding and casting. We all know that we make castings, we make MS castings, we make aluminum castings, we make copper castings, and we have very good examples like ceramic insulators for spark plug of a car. That is basically, or engine of a cylinder block of a car, cylinder head of a car. So these are all made by casting, and we do have forging processes where we change the shape of a raw material. Metal forming basically includes a large group of manufacturing processes in which plastic deformation is used to change the shape of the metal workpiece. That means you have to apply forces on the raw material and take it to plastic deformation stage so that the shape changes. Shape will only change if you take it to plastic deformation stage. So deformation results from the use of a tool, usually a die in metal forming, which applies stresses that exceed the yield strength of the metal. So you have to stress the raw material beyond the yield strength so that it yields. If it yields, only then you can change the shape. So these are some of the examples of formed components. A is bar stock, then B is fullering, C is rolling, D is blocking. That means these are components made by blanking, finishing, trimming. G shows the flash, and H is this is flash. Just see, this is flash here, this is flash here, this is flash here. This has to be removed, and these are the forging dies. Metal forming process, basically you have sheet metal forming or sheet metal working. Also we call it as press working. These are cold working processes normally, and you use a punch and die as we all know, and it is performed on metal sheets, strips and coils. As I discussed, that you make a car body from the plain sheet, surface area or volume is very large. In bulk deformation, compressive deformation force is there, deformation force is there. Deformations are very significant and there are massive shape changes. That means shape changes are appreciable. The starting raw material includes billets and rectangular bars. Just see the difference. In sheet metal working, you start with the sheets, strips and coils, whereas in other processes like forging, you start with billets and rectangular bars. Surface area to volume ratio is small. Now these are the processes under sheet metal working: bending operations, shearing operations. Shearing means cutting operations, deep or cup drying, where you have to make shapes like your tea cup. Rolling, forging, extrusion and drawing processes come under bulk deformation, where surface area to volume ratio is small. If you see the primary metal forming processes, rolling, forging, extrusion, tube and wire drying, deep drying, they all come under metal forming processes. Although punching and blanking operations are not metal forming process, these will be covered due to similarity with the deep drying processes. So, this is one of the processes. If you see the rolling process, here just see the thicknesses of the sheet is more here, and when it passes through the rolls, these rolls are rotating. This roll is rotating in this direction and this roll is rotating in this direction. So, one is they reduce the thickness of this sheet or strip, whatever raw material is there, and at the same time they also push it in this direction because they are both rotating. This roll is rotating in this direction and this roll is rotating in this direction. This is actual equipment. Just see, there are 2 rolls, maybe there can be 2 rolls, 3 rolls, 4 rolls, depending upon what is the reduction in thickness you want. So, this is example of flat rolling. That means this roller, these are the 2 rollers which will rotate in opposite directions, and this is the raw material, and as a result of this flat rolling, the product you get is this much. The thickness has been reduced. So, rolling is the most extensively used metal forming process, and its shape is roughly share is roughly 90% of the total forming processes. The material to be rolled is drawn by means of friction into the 2 revolving roll gaps. Both the rolls are revolving in opposite direction. So, material is automatically pulled into the rolls. The comprehensive forces applied by the rolls reduce the thickness of the material or change its cross sectional area, as we have seen it. Geometry of the product depends on the contour of the roll gap. That means what type of rolls we are using. What we have seen is flat rolling, but if I make a roller shape, I can get a I section from this, or I can get a T section from this. So, roll materials are cast iron, cast steel and forged steel because of the high strength and wear resistance requirements, because it is a hot working process. It is a hot working process. So, the temperature is very high, the wear rate will be very high. So, you need high wear resistance materials. Hot rolls are generally rough so that they can bite the work. That means they can hold the work and they can push it through the rolls, and cold rolls are ground and polished for good finish. In rolling, the crystals get, this is basically the basically grain structure gets refined. In rolling, the crystals get elongated in the rolling direction. In cold rolling, crystals more or less retain the elongated shape, but in hot rolling they start forming after coming out of the deformation zone. That means we can have both hot rolling and cold rolling processes. It says that if it is cold rolling, if the basic crystals of the material, they elongate in the rolling direction because of the pressure on the dies from the die or the rollers, and after rolling operation also they retain the elongated shape. But in hot rolling, as the product cools down, it starts to regain its original shape. The peripheral velocity of rolls at entry exceeds that of the strip which is dragged in it if the interface friction is high enough. That means the rollers will automatically pull it into it. In the deformation zone, the thickness of the strips gets reduced and it elongates. The increase in the linear speed of at the exit. So, the raw material is pulled inside automatically. You don't have to push it. You have to just bring it to the rollers, and it automatically is pulled into the rollers because the rollers are rotating and there is a lot of friction between the material and the rollers. So, these are some of the configurations. this is 2 roll, this is 3 rolls, this is 4 rolls, and this is a sequential. That means you reduce some thickness here from here to here, then you reduce more and you reduce more here. So this is called 2 high A, B is called 3 high, C is called 4 high, and this is basically a cluster mill. That means it is a cluster of rollers, and actual reduction is being done between these 2 rollers only. And this is a tandem mill, this is a sequential mill actually. That in sequence you go on decreasing the size, or you keep on rolling further and further. So some size reduction is there from here to here, then more reduction, then more reduction. So these are more examples of similar processes. That's in 3 high. You just see from here to here there is a reduction, but now from here to here there is a reduction, but then to save space and one roller, because the same roller is being used here also, so you again put it in the reverse direction. Now it has come from here to here, then you rotate it and put it again into this, and it passes through this. Now as I said, we can have L beams, U channels, I shapes, rail. You have seen railway lines, the shape is different, and we can have round and square bars through rolling. Similarly, there is a process called thread rolling, that you roll the die and deform the raw material to make the threads. We all have seen that we have cut threads on the lathe, we have cut threads on the milling machine, thread tapping we have done it, or we have cut threads by manually having a thread cutting tool, that is called a tap. But we can, when we have to do it in bulk, then you can use this thread rolling process. Well, like when you make small screws and all, you don't cut threads by any processes which I said, by neither by tapping, nor by lathe, nor by thread forming on the milling machine. You cut it by thread rolling. You have threaded rolls which are made to pass over the raw material, and threads are cut. So this is the thread rolling operation. Just see, these are the threads, this is the die, threaded die, and this is the raw material. When this raw material passes through it, the threads are cut. Just see. Similarly, there is a ring rolling. This is a small ring, and these are the rolls. This one roll, this is one roll, then this is controlling the diameter, for controlling the diameter and thickness, and this is controlling the height of this dimension. So you have, what we have done is, here we have transformed this smaller ring into a bigger ring. Now we have seen the forging process also. The forging is very old, and we have been using it very widely. So it is also a forming process. Just see, this is a raw material, this is the raw material, and this is a forging machine or a hammer, and this is the die. When this head, upper part, strikes this, the shape of this changes. So this is what we call it as, because material is lying in open, this is called open die forging. This one is called open die forging, and the shape of the material is not controlled. This is not controlled. This can expand freely. The height will decrease and the diameter will increase. It may not remain circular, although because the pressure is uniform on the billet, or this is the raw material, and the diameter is likely to remain same. This shape is likely to remain the uniform or round only, but there is no guarantee. There is no guarantee here. This is called open die casting, and you just hammer it from the top, and the shape of this changes, or the size of this changes. The length will decrease and diameter will increase. This is what we had is, this is upper upper die, this is the lower die, and this is the workpiece. You just press it. There is no control. This is open die casting. Whereas just see this. This is a closed die forging. This is the raw material. This is the raw material, and this is the shape we want. So we have done is we had started with this raw material. This is the die. This is the upper half, and this is the lower half. So what you do is you strike this material, strike this red shape, color material with the upper die, and as a result of this, because the material has been heated to a high temperature, it yields. When you strike with a heavy force, it yields and it fills the die. Just see, it has taken this shape. It has taken this shape. This may not be required because we wanted this to close, but this is what we call it as extra material, which we will have to remove. This is called flash. So I wanted only up to this straight line here. So this is a closed die forging where we have been able to control the shape of the component which we are likely to get from this. Similarly, this is also a closed die. We are able to control the shape here. Just see, the raw material may be flat, but we are able to control the flash, but control the shape of the component which is coming from the die, but at the same time we are getting some extra material which is flowing out of the die and is not allowing the die to close. So this is called flash. But we can have flashless casting also. Just see here, it is a very controlled. This is the upper half, this is the lower half of the die. Or this is called punch, or this is upper half of the die and this is lower half of the die. Here the material cannot flow out. It cannot flow out. So it has to remain within the boundaries. So this is a flashless casting. Just see, flash is extra material which is coming on the edges of the workpiece which you are making. But here we are getting flash, whereas here we are not getting any flash because we have not allowed it to have any space here. There is no space where flash can be formed. This is very controlled. So in flashless forging, work part is completely constructed in die. No excess flash is created, whereas here flash is created. So you can have cold forging or hot forging. Hot forging is when you heat the component or raw material. It is most common because you can have significant deformations with lesser capacity of the press. Whereas in cold forging, you do not heat the component. You do not heat the component, you apply force on the cold raw material. So you may need higher forces to get the same shape of the component, but the advantage of cold forging is that you get an increased strength. The components which are formed through cold forming are stronger than what you get in hot forging. So this is some processes which are going on. Extrusion is another process where you have the billet, you press it here, this is the force you apply, and this is the die through which the material passes, and you get a extruded product here. You get a extruded product. Extrusion is very common in plastic. Another example of extrusion, just see, this is the billet or the raw material which you are having, and what we want is, we want a product like this. This is the final product I want, right. So it is, we call it as, this is the side from which we are pushing the material, and this is the die. This is the shape which we want. The shape is the same or the reverse of what we want. The shape of this, the shape of the extruded product will depend upon the shape of the die. So you are pushing the material from here and you are getting the product here, extruded product. Now this is indirect, where you have the raw material here or the billet here, and you push the die against it. You push it and the extruded component comes in this direction. Here just see, the product is here and ram is, or the force is coming from this side, they are in the same direction, whereas here the force is in this direction and the product is coming in opposite direction. Wire drying you must have all heard. Large quantities of wires, rods, tubes and other sections are produced by drying process, which is basically a cold working process. In this process, the material is pulled through a die in order to reduce it to the desired shape and size. There are many wire drying small units you must have seen, you must visit somewhere, where you reduce the diameter just by cold working and pulling it through a die. So this is again the same thing what I have. Now come to sheet metal working. Sheet metal working is basically simply metal formed into thin and flat pieces. Very commonly used, is one of the fundamental forms used in metal working and can be cut and bent into a variety of different shapes. In our daily life also we use many products, and most common you can say is in your automobiles, in your two-wheelers, four-wheelers. There are many sheet metal components which are being used. The thickness can vary significantly, although extremely thin thicknesses are considered foil or leaf. Very thin thin components or the sheets are called foil, and the pieces thicker than 6 mm are considered plate. So sometimes we are asked the question, what is the difference between sheet and plate? So it is more than 6 millimeters or 0.25 inches, they are called plates, and less than this is called a sheet. Now what is the meaning of sheet metal processing? The raw material for sheet metal manufacturing process is the output of the rolling process. That means from the rolling process, whatever we are getting, we can go in for sheet metal components. Now sheets are also rolled. Typically sheets of metal are sold as flat rectangular sheets of standard size. If the sheets are thin and very long, they may be in the form of rolls. You must have seen that there are sheets rolled into rolls, because when they are produced in the industry, rolling mills, they are produced in long sheets and they are rolled for transportation purposes, because you can easily take them on a vehicle like trucks and all, or railways. So the first step in any sheet metal process is to cut the correct shape and size blank from the larger sheet. That means what is blank? Blank is basically the starting raw material on which you want to work. You see, nobody wants to waste material here. We should have the just minimum material or just sufficient material which will be used for making that component. If you remember, you must have studied the development of solids in engineering drawing. Here that knowledge will come into use. How much material will be used for making a particular component? So you develop it. You make a calculation and calculate what size of blank you need for making the sheet and cut it into pieces. Now the basic sheet metal processes involve shearing, bending and drawing. We will come to it. Just see, what is shearing? Shearing is basically cutting. That means what you have is, you have a die here. You see, die is integral part of metal forming. So in sheet metal forming also, you have a die, you have a punch here. This is the raw material. Just see, this is the raw material. So when the raw material comes here, the punch comes down, and this edge and this edge, this is the die edge, this is the punch edge. they have very little clearance between them. So, as it comes down, it cuts the sheet. So, this is basically a physical cutting. This is the punch which cuts the sheet. Now, there are two common operations called blanking and punching. They are similar. They are similar operations. Blanking and punching are similar sheet metal cutting operations that involve cutting the sheet metal along a closed outline. The difference is between blanking and punching is only which part you are using, whether you are using the cut part, the part which comes out of the sheet after cutting, or whether you are using the remaining material which is part of the raw material you have fed to the press. So, if the part is cut out is the desired product, that means let us say this is the sheet, and we have this is the punch, and with the help of this punch from this sheet we have cut this part. Now, if this is a useful product, this is called blanking, and if this is the useful product after removing this small part, then this is called a punching operation, right. Either this can be useful product which is used, then this is a wastage, this is scrap, or if this is useful product, then this is scrap. So, depending upon what we are going to use, whether this part, if this is the useful part, then this is called blanking, and if this is the useful part, this is called punching. Similarly, now we have a operation called bending. Bending is defined as the staining of the sheet metal around a straight edge, right. That means we had a straight sheet and we have bent it like this. Now, there is a neutral axis, just see this axis. Now, in the bending operation what happens is this area, this side, outer side here, it is stretched. This side is stretched, whereas this side is compressed, because there will be pressure on this, compressive forces will come on this and tensile forces will come on this part, and this is line which is called neutral axis, where there will be no stresses. On this side, inner side of this, there are compressive stresses, and on the outer side there are tensile stresses. Now, bending can be V bending, just see there is a die here, V shaped die, and you have a punch here, you force the punch from top and you get a V shape, you have a V shape of the product. Similarly, you can have a wiping die, where you, now this is this white color is the raw material and this is the die, this is just holding, and you have this punch. So, you just, the punch comes down, you see here it was hitting the component from top and you are getting a V. Here the punch comes down and it bends the component, just see here, it bends the raw material. Then you can have a rotary bending, that means this is the raw material, this is the upper die and this is the lower die, this is the ratchet. As you move this die, this ratchet comes down and it takes the shape like this and it bends the raw material. This is stretch bending, where you pull it from both the sides around a tool, the shape you want, what type of bending you want. The raw material is held from both the sides and you stretch it, you pull it like this. This is a gripper here, so you do not pull it from this side, it is a gripper here, you hold it from this side and pull it along this. Now, when you pull it, it will take the shape of the basic tool, or you can call this as a die, it will take the shape of this die, just say this. This is the shape, this is the die, this is the roller is the die. So, you pull it over it and you gets bent. Now, drying operation is very common, where you make hollow shaped parts from sheet blank. What you have is, you have a blank here, just see, you have a blank and you have a punch. This is the die. Now, these are the blank holders. That means, you put the blank here and you put the blank holder. With the help of blank holders, you hold the raw material here.